A very pleasant morning, my dear children. This is Fancy Joes from Mount Carmel School. Today I am here with Class 6 Physics. Our topic is light. This is the second part of this chapter. Let us get started. In this video, we are going to cover rectilinear propagation of light, activity to show rectilinear propagation of light, the pinhole camera, working of the pinhole camera, characteristics of the image formed by the pinhole camera. So first let us see what is rectilinear propagation of light. Here I have given two pictures. One is beam of light produced by torch. Second is beam of light produced by a projector. What do you observe? In both these pictures, light is traveling in a straight line. You can see that from both these pictures, light is traveling in a straight line. Light is not bending anywhere. So, the property of light traveling in straight lines is called rectilinear propagation of light. Now I will show one activity for this. This is one activity to show rectilinear propagation of light. Here you need some materials, one candle, 3 cardboards of same size. Now how to do this? Take 3 cardboards of the same size, that is A, B and C. Stack them together and make a hole in each by driving a nail through all of them. That is, keep all the 3 cardboards together and make a hole through them so that all the 3 holes should be in a straight line as shown in the figure. Clear? Now, mount each cardboard upright on the table. Mount each cardboard upright on the table, that is straight. All the 3 cardboards mount upright on the table. Now, take a candle with the wick at about the same height as the hole. That is, the candle's wick will be almost the same height of the hole. Here, now adjust the 3 cardboards A, B, C in a straight line as shown in the figure. Now check if all the 3 holes are in a straight line. Now you observe through the cardboard C. What you can see through the cardboard C? Now you can see the light from the candle to the cardboard C. Clear? Isn't it? This shows that light is traveling in a straight line. Clear? Now, suppose if you are changing the position of B a little bit, almost 1 centimeter, then you can't see the light through C. Why? Because now if you are changing the position of B, then the light cannot travel through the straight line, so you can't see the candle light. Clear? So from this experiment, you can observe that light travels in a straight line and we can't see the light when we move the card. This property of light is called rectilinear propagation of light. Hope it was clear to you all. So now let us move to pinhole camera. What is a pinhole camera? A pinhole camera is a simple camera without a lens with a tiny hole. It is a light-proof box with a small hole in one side. Okay, that is it amazing? That is a camera without a lens. Yes, it is amazing. That is, you all know that cameras are having lens. But in a pinhole camera, there is no lens. But there will be one tiny hole. Okay, these both are pinhole camera. Through this tiny hole, the image is forming in a pinhole camera. Okay, now let us see how does it work. Here I am going to show how a pinhole camera works. The pinhole camera works on the principle that light travels in a straight line. Okay. Now here, the pinhole camera, this is the pinhole camera, has been pointed at a distant tree. Okay, from a distance from a tree. If we look into the pinhole camera, by keeping our eye at its backside, that is, if you are looking at the backside of this camera, you can see an inverted image of this tree on the screen. Okay? How this image is forming? How this image is forming? This image is forming because this light travels in a straight line and enters into the pinhole and forming an inverted image. So let us discuss it in detail. Okay, I will tell you it in detail how this image is formed. Here, this is the ray of light. A ray of light coming from the top of the tree, that is, this we are marking as A, and passes through this pinhole in a straight line to form the image at a point A star. Okay? Next, another ray of light, B, it is traveling in a straight line and passes through the point P and form an image at a point P star on the screen. Okay? In the same way, each point on the tree AB forms its corresponding image on the screen between the points A star and B star. In this way, the image A star B star of the tree produced on the screen. Clear? That is, the light travels from the straight line A and enters through the hole B and forming an image A. Like that, all the light rays traveling through this pinhole and forming an image on the screen. Clear? This is the working of the pinhole camera. Now, let us see what are the characteristics of this image. Here I have given two pictures, that is in this both are pinhole camera is forming images. Both these images are inverted images, isn't it? Upside down images. How these images are inverted? Okay? A pinhole camera forms a real and inverted image of the object. Here, due to the intersection of light rays, that is one ray from here and one ray from here, both the rays are intersecting here. This is why the image is inverted. Clear? This is why the image is inverted. The upside down of the image, okay, the upside down of the image of an object formed by a pinhole camera is called an inverted image. That is, upside down image is known as inverted image. And always the pinhole camera is producing an image on the screen. it is producing an image on the screen. So it is known as a real image. Okay. So what are the characteristics? One is it is an inverted image, and second is it is an real image. And now what about the size of the image? Usually the size can be small than the object, but it can be equal or bigger than the object as depending on the distance of the object from the pinhole camera. Farther the object from the pinhole camera, smaller will be the image. Next, another point to be noted is that the image formed in a pinhole camera is of the same color as of the object. That is, here you can see the same color of the object you can see in the image also. Okay? And one more point is here, that is, if you are keeping the pinhole is small, so your image will be sharp. That is, if you are keeping the pinhole is very small, then you will get a sharp and very clear image. So this is what about the characteristics of the image formed by a pinhole camera. So in this video, we have seen what is rectilinear propagation of light and the working of the pinhole camera. Hope this video was clear to you all. Thank you all. Stay home and study at home.